Good evening and welcome to Lowell Observatory's ongoing celebration of our historic 24-inch refracting telescope sitting behind me. Sitting next to me is Dr. Bill Sheehan, a noted astronomical historian. And we're going to celebrate the Clark again tonight. We're going to talk a little bit about history. We also are going to be looking at the moon, and we'll flash to views of the moon off and on. We have it right now. It's pretty cloudy tonight. And we do have the total, or the partial lunar eclipse later. 97% of the moon is going to be eclipsed, and we're doing programming with that later on. So we're not sure what's going to happen with the clouds, but we'll try to view that. And then we have our educators coming on that'll be talking all about the moon and eclipses and how they work and what to look at and all that sort of thing. So to start off with tonight, the Clark 125th, 125 years ago, Percival Lowell started using this telescope behind us. And it was used initially in Mexico and then brought back here, and it's been sitting here ever since. And so this year we've been celebrating it every month, and kind of following the pattern of our earlier programs, we're going to talk a little bit about some of the early history of the telescope, a different component of it. And then we'll talk about some of the research that was done with it. And since we have the moon is so prominent tonight, we're going to talk about the moon mapping that was done here. And then Bill is going to share some of his expertise, and we'll talk about how the mapping that was done here fits into the long era of moon mapping that goes back centuries and of course continues today. So I'm going to start a program here. And what we're going to talk about first of all is how they moved the telescope dome. This telescope was built in 1896. There's no electricity here. And so how do you move a dome that's 40 feet off the ground, weighs a couple thousand pounds? And how do you do that? Well, initially, they did it all mechanically. The dome originally sat on wheels. And if you look in this image, you can see right below the telescope, I'm using the cursor, there's a wheel, there's another one. There are a couple dozen of these wheels. And they had essentially a rope and pulley system that they pulled to rotate the dome, because you need to rotate it because there's a slit that opens, doors that open, that's how you look out. And then if you want to look at a different part of the sky, you rotate the dome around till that opening is pointing to the right part of the sky.
Kevin, does that mean that there would have had to have been an assistant just to move the dome when someone
There was.
observing?
Harry Hussey was an early assistant here, an Englishman. And Percival Lowell especially would want an assistant to do that sort of thing. So they tried that for several years, but when they brought the telescope, when they built the telescope, the top part of the dome was a framework of wood covered with canvas. And that was fairly light. When they brought it back to Flagstaff, where we get snow and worse weather conditions, they had to stabilize the dome and so cover it with wood and metal. And that made it so heavy that it didn't move very easily anymore on those wheels. So then they built these pontoons. And using the pontoons, they floated the dome in water. And that was a system that failed miserably almost from the beginning.
And it had to be salt water, right, in order to keep it from freezing?
Yeah, because it does get cold here. So they built troughs of copper, filled them with salt water, and then put the dome on top of these pontoons that floated. And that just didn't work very well. And so then they went back to the old metal wheel system. We had electricity installed somewhere 1905-ish or so, we're not quite sure. And so then they used electric motors to move it. And then in 1960, V.M. Slifer, a longtime director in science circles, most known for detecting the expanding universe, when he retired, he made a donation to the observatory. He donated a set of tires, Ford tires, and that's what the dome sits on now. And in fact, as we're sitting here tonight, we might have to pause for a little rumble, and that's when the dome is rotated a little bit.
So it was a nice gift for retirement.
Yeah. Oh, I could always count on Bill. So through the years, there's been a lot of different ways they've moved it. You do based on what resources you have. There's no electricity, so they had to try, different methods. using rope and pulley, floating in water. And then eventually electricity came along, went back to the metal wheels, and then finally the rubber tires. And just earlier this year, we replaced all the tires. And generally in the past, they retire one or two, or replace one or two tires at a time as one goes flat, because they do go flat. Not on the tread, but on the sidewall. But earlier this year, replaced them all. And you can see they each have their own axle. You pop it off its axle. They have a pneumatic tire jack that jacks the entire dome up. And then they can take the tires off and so on. So it's a pretty ingenious system. And that's one of the many things that makes this telescope and dome so personal. These 4 tires, it's just, there's not a telescope dome besides this in the world that sits on 4 tires. It's part of the personality of it.
Right. And most of the others still use metal wheels, or how do they do their?
Yeah, metal wheels. If you go out to Lowell Discovery Telescope, it's the same idea of rotating the dome, but metal wheels that are probably easier to use and don't need as much replacement. But this has so much character.
How many tires are there? Has anyone counted them?
There's 32.
32.
And you know, for years, there's hubcaps on all these. They're not in this picture. If we go back one, you can see the hubcaps that say Ford. And for years, one of these didn't have the tire on it because it didn't fit. And so finally, when we renovated the dome a few years ago, we took care of that. So another neat part of this dome, part of the personality, you've used this telescope a lot, Bill. I know that there's a lot of personality to it. So let's stop the program here for a second and talk about some of the research that was done here. Throughout this year, we've talked about a lot of different research. Of course, VM Slifer's work on so-called recessional velocity, meaning objects that are generally moving away from us. And we've talked about Percival Lowell and his studies of Mars. We've talked about other planets. Tonight, we're going to talk about something that happened in the latter stages of research with this telescope, and that was moon mapping. In the 1960s, in support of the Apollo program to get astronauts to the moon, you know, one of the things, if you're traveling to a foreign country, you take a map so you can figure out where to go. If you're going to a foreign world, you need a map to figure out where to land, where the best features are, you know, so you can target what you want to study and so on. And so for almost 10 years, this moon mapping project went on here. And we're going to show a few slides of this, and then we'll talk about just moon mapping through the years. So I'm going to share the screen again. And while I'm doing this, we had a question from somebody wondering if we've had a flat tire. And we've had lots of flat tires, in fact, in here. And even something that's a little bit interesting, Jim Christie, who discovered Pluto's largest moon, Charon, in the 1970s, he was in here earlier in his career, and one of the tires had a blowout. And he said it was like an explosion going off in here. It just reverberated in here. In my time here, I've seen flat tires mostly that are affiliated with the motors. There are 3 motors, and those are the tires that are doing all the work. The other ones just support the weight. So we do have those. So let's talk about the moon mapping. And we've done programs about this before, but just to kind of briefly highlight it, this program ran from 1961 to 69. It involved scientific illustrators like Pat Bridges right here. And Pat came from the ACIC, the Aeronautical Chart and Information Center, that was based in St. Louis. She was one of the first ACIC people to come to Flagstaff and to Lowell to do this. So she used airbrush. And in fact, if you want to learn more about the airbrush technique, later tonight during our coverage of the eclipse, Sarah Bircher, who manages our public program, she's going to talk about kind of the technique of airbrush and how they use those to make drawings. As you can see here, she has a photograph. So what they would do is get basic photographs of the moon, and the photographs just weren't detailed enough. And so they get photographs, view through the telescope, wait for those moments of exquisite seeing, and then sketch in the details. So it's kind of a combination of scientists, of artists. This gentleman, his name is Bob Mulfair, and Bob was a photographer. And so he was one of the guys, the main person for several years that would photograph the moon. And then that's, what they would use to compare and make the drawings. And I like showing this picture because this is what Bob looks like today. And when I say today, really it's more like 3 days ago, because we just visited a few days ago, and here's Bob with one of the maps that he was responsible for. And so, Bob, it's great to have you still being able to share the stories with us.
And those maps are available online, aren't they? So if people want to download them, they can. Or...
Right. These are all available. I can't remember offhand the site, but if you looked up moon maps, I think LAC moon maps, which is one of the series, you can find them, and they're all digital. They're also high resolution. So I've printed them off, and you could, you need a big printer to do the whole thing. But if you do just a section, you can really make it out nicely. This map is actually a section of the moon Purback, and there's the Purback cross, which is only at certain times right around first quarter moon, when the shadow is just right going over these craters, you see a big X on the moon, the cross.
Yeah, didn't someone think that was an artificial construction at one time?
Of course they did.
Yeah, Christian thing.
This is, it's kind of hard to tell without seeing the thing in person, but you see the detail. Again, this is all done by hand using airbrushes, and the attention to detail, even the angle of the sun in the shadows, they did the same angle that the astronauts would be flying in at.
Wow.
So that, this is what it's going to look like.
And that looks just like what you would see if you look through this telescope in perfect seeing.
Right. It's so detailed.
Yeah,
and this is a project we talked about of taking these maps and viewing through them today and seeing the comparison.
Well worth doing.
This is a team, the last part of the moon mapping program. We not only made these maps, but also made a globe. And this is after Pat Bridges left Lowell, she left to raise her family, raise her kids. Jay Inge became the primary illustrator. Terry McCann, who just passed away last week, and some of the other mappers, they're with these gores of the moon, sections that you put together to create a globe. And so this was the last kind of product of this. After 1969, we started getting orbiting missions going around the moon, and you can get a lot better detail. But the mapping still continued. So this mapping here was the last major research done with the Clark telescope, and it was fundamental to the program, to the Apollo program. So Bill, let's talk a little bit. That moon mapping went on for 9 years here. But moon mapping has gone on for a lot longer than that. Maybe we can talk about that a little bit.
Obviously, the moon is the first thing that anybody that has a small telescope looks at. Often they'll pick the time of full moon to start their observing on the assumption that that would be the best time, as tonight. But the reality is the best time to observe the moon is when it's at a phase which isn't full, and where you have these shadows that highlight all of these fascinating features. And I still remember the first look I ever had through a small telescope.
With Galileo.
Yeah, well, it was a little before his time, but it was just utterly staggering to me. To see all of these features so cleanly chiseled and sculpted and real. But anyway, the history of moon mapping really began with Galileo, who was, of course, someone that lived in the Renaissance and had considerable skill as an artist himself. And these are some basically plein air, in other words, done at the telescope drawings that he did, which really show amazing detail. And so he was not only a pioneer in terms of building telescopes, but he was also a pioneer in seeing this kind of detail. And these kind of drawings still hold up pretty well if you were to go out and look at the moon through a small telescope.
And really, this is for starters in astronomy. You start with a telescope that maybe is the same size as Galileo's, maybe a little bit bigger, but this is kind of what you're going to see and draw.
Yep.
Maybe, I mean, mine wouldn't be quite as accurate as this.
Right, and Galileo did correctly infer that these were mountains and craters. He didn't use that term, but that's the term that came into use. And obviously, there's a lot of detail there that made it very challenging to map. And in the earlier days of astronomy, the main reason that people were interested in mapping the moon didn't have to do with wanting to understand its geology as today, or obviously to make maps that astronauts could use, but it was really tied up with this problem of longitude at sea. Mm-hmm. The idea was that if you were at some point of unknown position on the Earth's surface, if you were to observe the moon through a telescope and find out precisely when certain features became illuminated, which could be calculated in advance, then you would be able to work out your longitude. Mm-hmm. And that was the big, sort of moonrace problem of the 18th century.
And that was Galileo tried to do the same thing with Jupiter's, the Galilean satellites.
Yeah, there are a number of different things, approaches that were tried. He actually had designed a helmet which a person could wear and try to see the satellites.
On the ship on the ocean.
Right, if you had any kind of neurological disease that caused you to have the shakes, you were immediately excluded as the observer. Can we see the next one, Kevin? Well, these are examples of early maps. This is by a Jesuit astronomer named Giovanni Riccioli. It wasn't a very good map, but he was remembered because he was the first person to name the features on the moon in a way which is still used today. So all of these craters were named after famous astronomers, and many of them, not surprisingly, were Jesuits that he knew, and he even included one for himself. So there's a Riccioli on the foreshortened feature on the western side of the moon.
Now, Bill, before we go further, I should mention, you're speaking about this as an authority because, well, you are an authority. You've written books about the moon and Epic Moon. I think you have a copy of it right here. If you want to hold that up, we can. And a lot of the information that you're talking about is in this book.
Right, yeah, this is sort of the history of the moon in the telescopic era.
Yeah.
And so it does include some of the mapping that was done here at Lowell as sort of the final chapter of that.
Yeah, okay.
But yeah, fascinating subject. And one of the things that emerged from this historical study was that the kind of people that got involved in mapping the moon tended to be, for the most part, rather obsessional individuals because the amount of detail is just so overwhelming. And it would become essentially a life work to improve on a map that your predecessors had done by adding more detail. And so the people that mapped the moon tended to focus more and more attention on tiny features of the moon, little craterlets, pits, isolated mountains. And, that was all well and good, but it would turn out, ironically, that the most significant features in terms of understanding the way that the lunar surface was shaped are the large features that we can see with the naked eye, which include these huge basins that were formed by impacts. And so ironically, one of the things that emerged from my study, and I did that with Tom Dobbins and others, amateur astronomer, was that the more that people mapped the moon, the more detailed they got, the less they really understood the moon.
Yeah, that's a curious result. Yeah, not how you usually expect it to go.
No, you expect that the person that has the detail on hand is also the person that you would entrust with the big picture, but clearly those two things don't go together.
And I think one important thing to point out here also, in you're doing that book and a lot of your other research, is that your background is in psychology. And so that's a very different perspective than most historians have. And it really allows us to understand, not just look at drawings and maps and other things, but to try to understand, like you said, the people and the makeup of those people that did it and why they found it important and such.
Yeah, and we could go on for a long time about that, but the latest thinking about the way that we construct reality is that it's a controlled hallucination in a sense. In other words, there is an outside world out there that we come to know, but actually we build models, using our sensory system, different aspects of our brain equipment, and we create a model that is essentially totally inside of ourselves and try to match that to the outside world, such as the moon.
Mm-hmm. So what's your favorite thing to look at through the telescope? Was this the first fun thing for you to look at?
Well, I mean,
planet?
yeah, it really was, partly because of the fact that there was so much detail visible even in a small telescope. So the one I had was one of these much maligned department store telescopes that I got for $29, which was a lot of money at the time that I started, which, is sort of just about the time before the gold rush. But anyway, I saw a clear picture of the moon with only 35 times magnification. And if you work it out, essentially that means that even with that small magnification, you're seeing the moon as it would be through the portal of a spacecraft only a few thousand miles away. Mm-hmm. So, I mean, as a kid, you're just, flying through space with your little telescope and having dramatic vistas unfold before your eyes.
Well, let's go on with the moon. You have a couple more maps going on.
Yeah, just a couple more examples. The best examples are really of highly skillful artists. And one of the things that I don't think people totally appreciate is that what they see in some of these old drawings really depends on the technology that was used to do the reproduction. So this is by Claude Milan, who was a famous artist of Louis XIV era, and it looks almost like a photograph. However, if you magnify this particular engraving, what you find is that he used very fine lines. And so as you magnify this, the detail smudges out. Mm-hmm. And so every map that was produced, and that includes the ones that were done here at Lowell, really depended upon the nature of the technology that was used to create the map, and then in turn to make a reproduction of it, which obviously got better and better. So this map, even though it looks extremely impressive, and it is from an artistic point of view, it isn't nearly as good, when you get to small features as you might imagine.
But it's interesting, like you were saying, that as the mappers got more detailed, they were moving further and further away from understanding the scientific nature and geologic history of the moon. And so in some ways, space artists, not the scientific illustrators who are doing the detail, but space artists through the years who have drawn images of the moon as we see it, they maybe have captured that better than some of the actual mappers.
Yeah, and for the most part, people that have mapped the moon have been geodesists, people that knew a lot about surveying and precise location of features on the moon, and rarely a really skilled artist. This is a gorgeous moon map that was done.
I see some canals on here.
Yeah. Well, in fact, the rays from Tycho, that was actually mentioned by a Lick Observatory astronomer named W.W. Campbell as a rebuttal of Percival Lowell's observations of Mars, is that just because something looks like linear on a planetary body doesn't mean that it was artificial.
Now, I don't see Herschel's amps here either.
Right, yeah, a lot. They're just over there. This is by John Russell, who was an amazing portrait artist.
We're going to take just a quick brief because we're going to hear some noise. Sarah's going to move the dome in just a second, and that's to keep the telescope viewing the moon rather than the sea. Sorry for cutting you off there, but when it's time to move, it's time to move. So continue.
Well, and Russell actually used a William Herschel telescope to do this depiction of the moon over a long period of time. And I think this is about as close to photographic reality that any artist using the old methods of pencil, brush, and canvas ever succeeded in doing. And you can see all sorts of features on here that are readily recognized, like Palus putridinum, which I always thought looked like a plateau. There's Mare Crisium with some craters in it. Tycho, as Kevin pointed out over here, Grimaldi and Riccioli. So yeah, Copernicus, which has often been called the monarch of the moon. Just a spectacular view. And all of this only comes to life when you have a telescope. I mean, you might be able to see, some people claim to be able to see a few features at a crater-sized level with the naked eye, but I've never been able to do that. And something like Mare Crisium over here is about as small a feature as you can see with the naked eye. So this is about as far as one can successfully go with those old techniques. And there are other maps, but they're often much more schematic in nature. And some of the ones done just before the spacecraft era, before the Lowell mapping project, are so covered with detail that they're essentially illegible. They're just detail packed on detail, which shows what happens when you attempt to be comprehensive, complete, without necessarily having any idea what it is you're drawing. It's kind of like copying out a phone book.
Yeah. Well, something that is probably obvious as we're looking at this is we're looking at the face of the moon that we see here from Earth. And that's the only side we ever see from Earth, because the moon is tidally locked. We're always facing the same side. But you had mentioned spacecraft. So a spacecraft, that allowed us to go and see the other side and map the other side. So maybe talk about that a little bit, moving into the spacecraft era where we're starting to get, be able to see the entire moon.
Right. I mean, that's a really good point. For a long time, before spacecraft existed, the backside of the moon or far side of the moon, various terms being used, but not dark side of the moon. That's a malapropism. It was one of those kind of things that might be considered unknowable, that we would never know what the backside of the moon looked like, the side away from us. But yeah, it was actually a Soviet spacecraft, Lunik 3, in October 1959 that flew around to the backside, got some pretty poor quality images. Television was fairly new then, and basically it was just sort of a real streaky kind of series of lines, but it did capture some of those features for the first time. And among the sidelights of that accomplishment was that the Soviets essentially were able to claim naming rights for a huge number of features on the backside of the moon, including there's a Mare Moscoviense, the Sea of Moscow, Tsiolkovsky, which is a famous sort of visionary of space flight, has the most prominent crater on the far side of the moon. But this opened up a whole new era of mapping that was finally completed by orbiting spacecraft, especially the lunar orbiters. Although there was a small area that was missed by them, it was in shadow when the lunar orbiters, which were 1966, 67, were active. And this area is around the South Pole and was called the lunar incognita. And various people, including Ewan Whitaker, who was a well-known astronomer at the University of Arizona, spent a lot of time trying to map that area of the moon near the South Pole. And he told me that what really brought him into lunar studies, even though he was trained as a stellar spectroscopist, was that when he looked at the southern area of the moon, of course, the telescope inverts it, he felt that he was able to see the mountains along the southern limb as if he were looking at the moon from the porthole of an orbiting spacecraft. And in fact, we've now seen what that view looks like, thanks to the Apollo astronauts.
You know, something interesting about this also is we've looked through some drawings that go back centuries, and you know there's similar patterns. You were talking about the large craters, and you know what some people call a poodle over here, with the two legs and the body and the head and the tail there, and so it begs the question: we see that essentially the same look through centuries. Like, how much is the moon changing? Is it changing, or is it's always the same?
Yeah, well, it's changing on a small scale. And in fact, I mean, one of the things that has changed the moon is that we've ended up putting human footprints up there on
which we can't see from here.
Right. Although the Lunar Reconnaissance Orbiter has been imaging tracks of the various rovers on the moon, have seen the little rocket platforms that the lunar excursion models have blasted off from. And occasionally one will see new craters formed from impacts. And one of the recent news stories that has been circulating is that at least temporarily, we seem to have at least one and maybe other temporary moons beside the one that we've known from forever. And those small moons seem to be material from the moon that was blasted into space by large impacts in the past. So the moon is changing, but on the other hand, on the human scale, it hasn't really changed much just to give you some example, and these are based on data from the Apollo missions when they brought back the moon rocks. The lunar crater Copernicus, which is one of the mightiest and most impressive features on the lunar surface, formed 810 million years ago. Tycho, this really fresh-looking crater that has all of these rays, which are ejecta blankets from material that was splashed out from the moon during this impact. That's about 109 million years old. And the way that was determined was essentially one of these rays goes all the way up and crosses one of the Apollo landing sites. I think it was maybe Apollo 17?
Maybe, I'm not sure.
Right. Anyway, so that's how that was dated. So, you know, we're talking about prominent features on the lunar surface that are very impressive that were formed, you know, when there were still dinosaurs on the Earth and even further back. So, yeah, the moon is a Rosetta Stone, and we're really lucky to have it because it also is a key to understanding the history of our Earth long before not only the era of man, but even the era of life on Earth. And so as we've learned more and more about the moon, we've found that its history has been inextricably tied to our own. And the Earth and the moon seem to have formed and have been continuing this dance since within perhaps a few 100 million years for sure of the beginning of the solar system.
And that's something that Bill Hartman down at Tucson and others figured out from the rocks we brought back from the moon.
Yeah, it was really difficult to understand how the moon could exist. And in fact, the moon is really an unusual object. It's by far the largest satellite that any planetary body has other than Pluto, which maybe or maybe doesn't count. But there's lots of consequences for the moon's being companion with the Earth. Namely, it helps to stabilize the Earth's axis over a long period of time. It has slowly changed the Earth's rotation period. But there's a lot of speculation among people that are interested in questions about astrobiology, whether a moon like ours is needed in order for life to evolve to more advanced stages, or whether or not that might be a rare occurrence in other places in the universe. So we're lucky to have the moon, not to mention how lonely the nights would be, and how different it would be for poets and lovers.
And that's true. I mean, whether or not we need a moon to have life on Earth, the moon definitely impacts life on Earth, both the way we live culturally, like you were saying, the romance of the moon, the tides. There's a lot of things that the moon is really closely tied to our life. Timing, the months are defined by.
Right, and increasingly, I think the thinking about how life originated on the Earth and probably elsewhere has to do with these tidal areas, which are alternately moistened by the incoming tides, and then are exposed for periods of time that allowed life to get a foothold in the early ages of Earth's history as a what shall we say, incubator of future life forms.
Mm-hmm. Right. Well, we stopped sharing. I wanted to check with Sarah to see what the view is like, and yeah, I think we're checking in with live views periodically here, and we can't see these on our screen, but our team of Maddie and Heather behind the scenes are making all the magic work with Sarah Bircher, who's operating the telescope right behind us.
Yeah, it's somewhere in the middle now. It's very small view.
Yeah, okay. And so, so you're getting the views now, and you get an idea, it's not a great night for viewing with the clouds and such, but it's still, the moon is so bright. This is what we like about the moon also at the observatory. When it's cloudy, you can still see it even when it's kind of cloudy in the sky.
Well, and again, as we were saying before, I mean, the full moon is the worst time to look at it for detail because it's all washed out, and it's a little bit like if you go to the Grand Canyon. It's impressive at any time of day and perhaps even of night, but is essentially looking at the Grand Canyon when it's washed out in the light of the noonday. Mm-hmm. Versus either in the morning or the evening when these long shadows crawl across the floor of the Grand Canyon and everything comes into high relief. It's the same with the moon. So actually the best time to look at the moon would have been, when it was a half or a crescent, and then you see all of these things. And the moon, it looks like you have just towering mountains, and there are some high mountains on the moon that are actually not mountains created by plate tectonics like those on the Earth, but instead are basically the ejective blankets of these huge basins that formed. But you can see what look like jagged peaks by their shadows, and then as the day advances, within a day or two, these shadows disappear, and you realize that this is just essentially like a Foucault test being done naturally by the solar illumination on these features, creating these impressive shadows.
And, and speaking of apparent things you see on the moon and the shadows and the changing face, it was with this telescope back in the mid-60s that there were some green and red markings detected.
Oh, right.
The transient lunar phenomena. Maybe we could talk about that a little bit.
Well, right. I mean, one of the things, if you go back through lunar history, which is interesting, is that for most of the time, astronomers thought that the moon's craters were formed by some form of volcanism. Mm-hmm. And, they in particular were impressed with some of the volcanoes in Sicily and Italy, Mount Etna, for instance, and this area called Campi Flegrei, the field of fire, which is near Naples. But anyway, So they use these analogies, which weren't very good analogies, because if you actually profile the craters on the moon, they don't look in profile very much like volcanoes on Earth. But we kind of reason often imperfectly from analogy. But anyway, so with that as the predisposition, it was thought that maybe the moon hadn't completely expired, hadn't blown off all of its gases from its interior, that there might still be an occasional small volcano. And, because of the fact that there's so much detail on the moon, a German astronomer named Julius Schmidt, who is perhaps one of the most obsessive lunar observers of all time, had noticed a small feature that it had seemed to have changed between his attempt to map the moon in that area and an earlier map. And he thought this was a new feature, and it created a tremendous amount of interest. It's much more interesting to observe something that is subject to change rather than something that's totally static. Yeah. So this controversy continued really up until the 1960s as to whether the moon's craters were volcanic in origin or whether perhaps they were meteoritic, which a few people thought. And eventually Eugene Shoemaker of the USGS astrobiology geology branch here in Flagstaff was able to demonstrate was indeed the case. But that went right into the 1960s, and a couple moon mappers here named Greenacre and Barr were observing one night with the Clark, making their mapping routine, when they thought that this really brilliant crater on the moon, Aristarchus, which is the brightest point on the moon's surface, was ruby red. And they noticed some other features which also seemed to be red. Well, anyway, the long story short, they were fooled by chromatic aberration. Basically, the telescope has a lot of false color because of its being a lens based instrument. And also the moon was low in the sky. And so they were actually observing with another telescope on Anderson Mesa, and they didn't see anything like this. But it certainly electrified people at the time. Yeah, sure. But in retrospect, the three red areas on the moon would have been like if Mount Rainier, Mount Shasta, and Mount St. Helens were all erupting at the same moment, which seemed a little bit unlikely. Yeah, that'd be a massive thing. Yeah. Well, it's all part of the process of learning, and the chromatic aberration you talk about. Certainly, that's not limited to the moon. No, one sees that all the time, and in fact, that's one of the reasons actually why to get the best views with this telescope, unless you use a very specialized filter, you need to kind of stop down the aperture to 12 or 16 inches, which was what Percival Lowell always did. And that's one of the great things about this telescope. It's got a device. You turn a knob at the business end where the eyepiece is, and it's attached to a rod that goes all the way to the other end, and it can close the aperture down to 6 inches or up to all the way 24. So if we're looking at the moon, we can just reduce the amount of light coming in. Looking at a galaxy that's faint, you look at more, and that's a good way of getting around that aberration. Well, it looks like we're about out of time. We'll take a last view of the moon. We'd like to thank everybody for joining us tonight. Thanks for our behind the scenes team of Sarah behind us with the telescope, Heather and Maddie for making all the programming work. And thanks for joining us. And next month, we'll finish our celebration of the 125th anniversary of the Clark telescope. So we'll see you then. Thanks for joining us. Have some good viewing of the eclipse, hopefully.